Assessments. Wednesday, the 1st of March. Multiple choice test on heat, the work that we will have done up until then. So that's a computer test. You sit in front of the computer and hold focused and do the multiple choice. Okay? Because you like that. Now, there might be a test on the next section. I haven't yet decided.
Why is there 2 dates?
2 classes.
Which is ours?
Monday or Wednesday. Have to pick. Yeah. Yeah, they get to do it first.
Is the same test or different?
Same test. So now you can plot how to cheat. How do you get round it? Can you convince anybody from 9A to cheat? Okay, there may be another test on the electricity, which we do after heat. So there are 3 sections to the work this term. There's heat, electricity, and then building blocks of nature, as Ilmio puts it, which is the very, very small radioactivity and atoms, and the very, very big, all the astronomy and astrophysics stuff. It's a huge amount to do. Sadly, we don't often get to have enough time to tackle the last part of it. At the moment, there is no plan to do the national test.
Yes.
Okay? But there is a big experiment report to do.
Wow.
Is it alone or in pairs?
You will carry the experiment out in pairs. You will do the report alone,
Okay.
as usual.
Does the experiment, like when we do it, separate it all, or is it just the report?
Just the report. So I need to think about why you've asked that. Okay. So I hope you have all had a fantastic break. I hope your personal projects are going beautifully. You done it?
I've done the creative piece.
Excellent. Good.
Yeah, but the
Good.
creative piece is like,
Sadly, all the marks finally end up going on the final report, not the creative piece, which is insulting to your creativity. Does mean if you want to play the system, you have a completely failed creative piece and you write your report as an evaluation as to why it failed. So, okay, so as a Brit, of course, I'm obsessed by the weather. Very, very upset by the weather at the moment. Why? Does anybody else share my upset? Why?
Because we get snow and then it goes away.
Yeah, we've got snow and then it goes away. I mean, look at
It's
that.
not gonna go away because it's gonna get like minus again. That's what we thought.
Yeah, but in the meantime, what are the what's it going to be like tomorrow? Icy, very, very icy.
oh, today is also Wednesday.
Today is also icy because we've got water on top of softening snow.
Water. It was icy.
Yeah, yeah. And actually, what happened, I believe, is that before Christmas we had a great big melt, a thaw, and then it all froze, and then we got really cold temperatures, and we got beautiful soft powdery snow that just lay like millions of little ball bearings over the top of the ice, creating a very, very low friction surface. Oh, the joy of it. And then look, we've got -10 here. What on earth is going on with the weather? Okay, this is one of my favourite sites. Nerd that I am, I have another favourite site that I discovered. windy.tv, which I can type. This is vaguely related to physics. I've seen this before, this site. No? Oh, the nerding of it. So, the graphic, yeah.
Like, doesn't it show like the Gulf currents?
Yeah. Yeah. Have you seen this? Have you looked at this before?
Probably I saw it like on a weather report or something.
Yeah, okay. Somebody set up, some nerd somewhere set up a website that used Google Maps and used wind speed data because he was into sailing and he wanted to look at the winds, which is why it's windytv.com. And I don't know where he gets his data from, but you can see from the size of the smears here, this is now Wednesday, 11 o'clock, you can see the wind speed and direction. So we've got a strong wind coming up over the sea, and you get stronger winds over the water areas generally. And the homepage comes up with the wind and the colour for it. I think you can just about make that out. Then you can change that to temperature. And temperature is fairly uniform at 0, -5, warmer over the seas. But, yeah, we got more detail there, or going the wrong way. Still going the wrong way. What a fool. Zoom out, zoom out, zoom out. Give it enough time to catch up. And it's showing the temperatures. So -35 is the purple. And then we've got positive temperatures. So actually there's a big freeze going on all over Europe. Air pressure. And it's the air pressure that determines the change in the weather. So we've got very windy here. There's a center of low pressure here. Here we've got high pressure. And it's, oh, let's see how it will take to load that up as well. There, so you can see the pressure current. That's quite pretty, isn't it? And the North Pole has nothing, probably because there's no data. We're getting very, very extreme changes in temperature. So it's going from +3 or +4 down to -20 the next day. Now that is weird. What drives that sort of big temperature change? Lily, what are you say? No, it's not. It's not as huge as that. Yeah.
I watched the news report and they said something like Siberia had a big wind coming, or something like that.
It's the air pressure changes.
China.
China. We're going to blame China for everything?
Yeah. China is global warming.
And what are you blaming Russia for? Are you really going to the Trump side? Let's blame China for everything. My goodness. My goodness. No, it's going to be pressure changes. Now, big wind from Siberia. I'm getting dizzy with that. Let's go back to the wind. Hey?
Can you do the date on the website? Like a date that has already passed.
No, it's actually, this is live right now. Yeah? Okay. So, Siberia's freezing. Finland is warming up. Okay, if it's warming up, there's warm air coming to it, and that warm air is coming from the Atlantic. So, it's going to freeze tomorrow, yeah? So, let's go to Thursday.
Whoa.
Friday. cold air is muscled in. The wind direction is changing to be more southerly. If you look at it carefully enough, in more detail, the wind is going to drive the temperature changes, and the wind is driven by the temperature of the land and sea. Look at that. Okay, we've got strong winds here over the North Sea. Let's go to the temperature part of it. It's warmer. That wind hits the cold air of the Norwegian mountains and is going to go back, and this area is still going to be cold. No mountains here. As a barrier, we get all that wind from Russia and Siberia. Okay, enough of the geography lesson, or the weather lesson. How is this going to relate to physics? Well, over the next few weeks, you are hopefully going to understand a little bit more about climate because of understanding heat. So, little bit of a brainstorm diagram or spider diagram. We have been talking about the weather. Because, yeah, won't be very big. We've been talking about the weather because it's what obsesses most of us at some point in our lives. And most people living in Finland, you either love the winters or you hate them. Love the summer's days. Or I don't know many people who hate them, apart from mosquito haters. Really bad mosquito haters. Okay, so what are we going to look at? We're going to look at how heat moves. So heat movement. I'm talking about that with the wind a little bit. The things we're going to look at there are conduction, convection, and radiation. Have you heard of heat conduction?
Yeah.
Good. Heat convection?
No.
Okay. Heat radiation? That's okay. I will define all these terms and give you the finish later as we get on to them. And with that heat movement, we are generally at the moment looking to keep warm, but not to overheat. Because if you get very, very sweaty in your outdoor gear, like some of you are doing at the moment, then when you go out, if it's very, very cold, then you can have problems. Okay. And I wasn't looking at you, actually. I was looking more towards the back.
Cold.
You're cold? Yeah, okay. I mean, it's not massively freezing out there today. You won't have too many problems. It was just a snide remark about taking your coat off. What else do we focus on with the weather? Well, I've talked a lot about temperature. How does heat determine temperature? And in English, they're completely different words, but in Finnish, it's wonderful. Heat is lämpö, temperature, lämpötila. And that, I think, is really visual, because if I understand the weird Finnish word of tila, it's like space, isn't it? So it's how the heat is distributed in a particular space. And we'll talk about the measurements of temperature, which we might get onto today, we might not. Yeah.
Attila can also mean like state. like the state of something.
Yeah. To me, that doesn't make it wrong. But like the heat state is if something is warm or cool. I like the way that the words are actually linked. Yeah, whereas I've actually heard British kids say, oh, what heat is it on the thermometer? Because they don't get the idea of heat and temperature being different, because the words are really very well related. But if we finish logic, it kind of appeals. Okay, so heat, temperature, heat movement, expansion and contraction, thermal expansion and contraction. Things get bigger when they get hotter. A general rule, it's not always the case. Any questions? I know it doesn't sound very exciting. So let's start off with, we can fill that diagram in a little bit more when we've done the subject, when we go back and look at it for some revision. That might be useful. So if you want to start at another page, you can pause. Let's measuring temperature. So we need two things to measure temperature. The first is really obvious. Yeah, a thermometer. What does a thermometer have on it that allows us to measure temperature? William?
Alcohol, or in some cases it has the metallic chemical.
Mercury.
Mercury.
Alcohol.
Okay, listen to the question again. You're completely right. What does the thermometer have on it?
Scale.
A scale.
Boom.
Okay. You need a thermometer which has a scale, and then what's in it, you've said mercury, which is the silver stuff, could be alcohol. What's important about that thing, that substance that it's got inside it?
It expands when it's warmer.
Good. It does something different when it's warmer. Very good. Okay. Inside it, it has got something that has a property which changes as heat is absorbed or released. Okay, e.g., liquid expands when hotter. Something like that.
Why is there, when there's mercury, and there's at the bottom there's a little ball that has more?
It's the reserve where it's actually an expansion space. So that when you start with a fixed amount of mercury that you know is going to cope with high temperatures and low temperatures. So the amount of mercury doesn't actually change, but the reservoir, I mean, I suppose it depends on the way that it's manufactured. You could have a very, very large bulb of mercury. That's not such a good idea because mercury is toxic. Or you could have a very, very small bulb of mercury. But you need some supply of it in there. And you also, where there's a gap at the top, depending on the air pressure in there. Some of the mercury, if it gets hot enough, it might become a vapor or not. So it's a bit of a balance between the two. A bit of a messed up explanation, but you basically, it supplies the thermometer with it. Gorda.
How do the electronic thermometer work?
Well
They
done,
also
you've
have-
spotted it. What if you have got something that isn't like a physical object, you've got something electronic?
Yeah, sometimes they may have some wire or something which goes out in the air, then that kind of measures.
Yeah, the temperature probe that's on the end of the wire, its property is its electrical resistance that changes. So then if it's got the same voltage going across it, we'll study this more when we do electricity, if it's got the same voltage across it and the resistance changes, the current changes. So then you get a different reading. Sauna thermometers. Don't use liquid, don't use anything electronic.
They use a metal, like it's like a spring, and then
Yeah, use a metal spring. Talk more about that on Friday as to how that works. That is a thermometer.
Oh.
I know, pretty thermometer. Not very accurate, but it's good enough. We could talk more about that
what does
on
it like?
Friday.
How can you know what's the like how?
Because those little metal discs at the bottom have got numbers on. So I know it's 20 degrees Celsius at the moment, where that thermometer is, because 19 is at the bottom and 20 is above. Neat. I'll explain that on Friday. William.
Well, most like normal thermometers made out of glass instead of other materials.
They can be made out of plastic as well, but liquid and glass thermometers, just because it's a convenient, transparent material and it's always been used, I think, to be honest. It can be molded and shaped easily. Okay, I want to talk about this scale first of all before we go on to thermometers. What scale do we use? Celsius. We use the degree Celsius. Okay, so the units are degree C. The degree is a superscript, so it's at the top, and it is before the big C. And yes, papers get it wrong. Okay, that is the degree Celsius, named after Swedish scientist Celsius, who himself gave the scale a different name. Used to be called, do any of you know it? And don't say the F word, that'll just annoy me, because it's not. No, centigrade. Have you ever heard of degree centigrade? Yeah. And about 30 years ago, it was changed, and in common language like weather forecast, centigrade disappeared.
Why?
Anybody think why?
He died.
Celsius died? No, Celsius was long dead. It wasn't scientifically accurate to call it centigrade.
Why?
William?
Is it because it has the word centi in it? on it?
Yeah, say a bit more.
Mm.
It doesn't have anything to do with meters.
You're,
It has something to
you're
do with like
both
centimeters.
almost there. You said it doesn't have anything to do with meters because of centimeters, yeah? How many centimeters in a meter?
It's 1/10 of the whole unit.
So close.
100.
100th. Anything with 100 divisions
It's called
is a centigrade scale. Centi, 100, grade, graduations, gradations. How many grades are there on this scale? 100. Just like centimeters and meters.
Also,
Just like,
a ruler, like 1 meter ruler.
yeah, meter ruler. Also, cents in a euro, cents in a dollar. A cent is just 100th. A centigrade scale is just a scale divided into hundredths. So I said, oh, yeah, this isn't specific and nerdy enough. We have to call it Celsius. Because it is a 100-degree scale. Why? Well, 0 degrees C, 100 degrees C. These are what are called the fixed points of the scale. These are really, really important because it allows people to make thermometers. What is famous about 0 degrees Celsius or special about it? It's really
Freezing
obvious.
point of water.
Freezing point about water. Freezing point of water. At normal atmospheric pressure and pure water.
How do they then make that? They just know that. Did they just sometimes say that, okay, this is 0 Celsius when that mercury is at this point?
Yes. Celsius did that. He was the first guy to actually say, well, as far as we know, let's produce a scale.
He just set the scale. And then
Yeah.
We're being followed for hundreds of years.
His stroke of genius was saying loads of people could make these thermometers. You can make your own thermometer. If you have a property that of something that varies with temperature, you stick that thing with the varying property in melting ice, you record that value of how big that property is, that's 0. Stick it in steam and water mix, you can record that, and that's 100. So that useless item at the moment, I could calibrate it. I could add a scale to it. Yeah. Make your own thermometer. But what the beauty is of the 0 and the 100 being related to water is that it's an easily available and repeatable thing that you can get if you have got pure water, if you have got ordinary atmospheric pressure.
You know the thermometers, like you measure if you have like fever?
Yeah.
Some of them like you put in your armpit or stuff like that. How are the ones that you put in your ear? How does that work?
Hair,
No,
Ear.
ear,
Like, how do they work?
vile things. You shouldn't stick anything smaller than your elbow in your ear because it could damage the eardrum.
That's more
The
accurate.
ear is, it's got airflow in it, the ear canal, and it's actually quite a small opening, small orifice. And because it's more inside your body than your armpit, it's regarded that with a small metallic sensor, you can do it fairly easily. You can get a fairly accurate report. I've got to admit, I've never got an accurate report of an ear thermometer. Okay, liquid in glass under the tongue. Yeah. Or the unpleasant rectal way of doing it. Aye, yes. Okay, so, the F word.
Fahrenheit.
What did Fahrenheit do? Okay, if you are in the USA, you have to learn to speak Fahrenheit. What did he do? Freezing point of water? Anybody know?
Isn't it 32?
32F. Well done.
It's confusing. It doesn't go to like minus.
It does.
Well, it does, but it's gonna get really, really cold.
Hey.
What's the boiling point of?
92.
Anybody know?
You're like 300 something.
You're closer than 92.
300.
130. No, and
200. Oh, what?
Exactly. Why?
so it doesn't go the same scale.
There's a video
It's-
of this.
It's
Like,
more
what he did.
accurate.
No, it's not.
Sinakaliisa enemmän niitä
There's a.
There's a video on YouTube where they explain like what he did and like why.
Oh, okay. I will try and look
What
at
is
it.
it skill based on, or like? Wow.
Okay, he obviously Fahrenheit used different fixed points. He didn't go for the sensible figure of water always boiling at 100. His 100F, human body temperature. Trouble is, our body temperature changes. We don't all have the same metabolic rate and the same body temperature. 0F, he based it on something, apparently there's a video, so I'm sure I can find it and we can watch it. Thank you again, chief video spotter. But it's not a centigrade scale, because there's not 100 degrees between these two fixed points. And it's just used historically. If you grew up with it, then you get used to learning with it. You just get confused if you talk to lots of people in the USA. I think Canada's gone Celsius. Britain has mainly gone Celsius. I don't know anywhere else that
But
does.
isn't there like 2 remaining countries that use the scale?
USA and
I don't remember.
I don't like.
probably no. Don't say it. Don't get
Isn't
involved.
there like a
in this.
third one? Like,
You're looking at that clock, willing
Where
it,
do
willing it, aren't you?
Where do they use Kelvin?
Nerd labs. Kelvin will. It's Kelvin's a scientific unit. In fact, in the USA, in classrooms, in science, we use Kelvin. What? Vicky, what were you going to say?
Oh no, I was gonna answer like who's in scientific.
Oh, I'm sorry. Yeah,
What's the
nerdery.
what's like
Boiling point of
boiling
Kelvin.
point and yeah.
In Kelvin, we'll do this on Friday with 273 degrees Celsius and 373 degrees Celsius. So it is a centigrade scale. Okay, thank you very much. No, it's not.